Welcome everyone to this quick crash course overview lecture on NumPy, which is a numerical Python library, and we're essentially just going to show you the very basics of it and how we're going to use it in this course. Let's open up a Jupyter Notebook and get started. Alright, so here I am with a new Jupyter Notebook, and the first thing I'm going to do is import NumPy as NP. And let's go over a couple ways that we can create arrays. So we're already familiar with a Python list, 1, 2, 3. Which is elements in a sequence, and if I want to convert this into a NumPy array, then I can say np dot, and if you hit tab here, you'll notice that there's a ton of functions that are built into NumPy. The majority of these we will never use, but we may be using array, so you can cast or really transform a list into an array. So if you run that, you can see now it's an array, and if you check the type of this object, it's no longer just a list, but instead it's a NumPy nd array, meaning n-dimensional array. Okay, so then we could also save this or assign it to a variable and then call back that variable later on. And again, remember, it's just Shift-Enter to run a cell. Now, that's the way you can cast a list into an array, but lots of times we'll be using a lot of built-in functions with NumPy to create large arrays very quickly. So one way to do that is by using the arrange function that's built into NumPy. Again, just clicking tab there to autocomplete. And arrange, the way it works, if you do shift tab here, it'll basically tell you it's essentially NumPy's version of Python's normal range function, where you indicate a start, a stop, and then as an option, a step size. For example, I can say start at 0. Whoops, let me make sure I click on that. Start at 0, go up to, but not including 10. And then I'll see 0 through 9 here. So you can see that we have 10 elements in an array, evenly spaced by 1. Don't be confused by the fact that it doesn't go all the way to 10. It's because it's going up to, but not including that last stopping. So if you actually wanted this to be 0 through 10, you would then have to put in 11 here, and then you would get back 0 through 10, which would be 11 elements. Now, if you actually want to indicate a step size, for instance, you want all the even numbers, as a third argument, you can indicate, hey, go in steps of 2. And then when you run this, you can see you have 0, 2, 4, 6, 8, 10, etc. So that's a range, again, a start, stop, and step size, very similar to Python's built-in range function. Now NumPy also has lots of useful tools for quickly creating specific arrays, such as an array of zeros. So zeros can either just take in one digit or one integer, and it'll return back a one-dimensional array. You can see here it returned back 5 zeros. Or instead, you can pass in a tuple of dimensions. Maybe you want a 3 by 5 array or matrix, a two-dimensional array. And when you run that, you can see here I have 3 rows and then 5 columns of zeros. So that's the way NP zeros works. Essentially returns back an n-dimensional array, depending on what you pass in, the dimensions of that, where they're all zeros. And note that it has a decimal point here indicating that these are actually all floating points versus integers that we had over in a range. And a lot of times with the operations we perform with TensorFlow and Python, NumPy is going to be transforming things to floats to make sure that we don't accidentally lose information. Okay, so now let's go ahead and discuss a couple more ways of creating arrays. There's also a similar ones function, same deal here. If you pass in a single integer, it's going to bring back an array of ones. Note again that they're floating point numbers. And then we can do something like a 3 by 5, and let me pass that in as a tuple, although I believe it doesn't matter either way. Here we go, 3 by 5, 3 ones by 5 ones, and there's ways of creating linearly spaced arrays. So there's linspace, and basically linspace works by you providing a starting point, a stopping point, and then the number of elements you want evenly spaced or linearly spaced between the start and the stop. For example, if I want to start at 0 and go to 11, and I want 10 points there,